Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 2 paper from summer 2023. This paper is worth 120 marks in total, and this is the second video of 6. It will focus on questions 4 to 7, which account for 22 of these marks. Eduqas Component 2 papers are calculator papers, so a calculator should be used. A little disclaimer, there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 4. Reese owns a bakery. He recorded how many cupcakes he sold each day. The results for the first 4 days are displayed in the pictogram below. So here's our pictogram, and the key tells us that this shape split into 4 equal parts represents 12 cupcakes. So we need to be aware of that, that's important. Part A, Reese sold 42 cupcakes on Friday. Complete the pictogram for Friday. So each whole shape is 12 cupcakes, and each whole shape is split into 4. 12 divided by 4 is 3. So each of these little shapes, the triangles, are 3 cupcakes. So Reese sold 42 on Friday. So 12, 24, 36, 48. So we're going to have 3 whole shapes. But then we're going from 36 to 42, which is 6. So we want another 6. Each of these is worth 3. So we're just going to take half of that shape. Part A, part 2. How many cupcakes did Reese sell in total from Monday to Friday? Well, we know that Friday was 42. Thursday, 12. 12 and then 6. So 12 plus 12 plus 6. So that's 30. 1, 2, 3, 4 lots of 12. 48. So then we've got 12, 3, 6, 9. So 12 plus 9. And then 1, 2, 3 lots of 12 is 36. And then we're going to add all of those together. So we're going to do 36 plus 21 plus 48 plus 30 plus 42. Which is 177. So 177 sold in total. On Saturday, Reese sold 17 cupcakes. Explain why the key used for the pictogram is not suitable to show this. So the key, 4 of those equal parts is 12. So if we do 17 take away 12, that leaves us with 5. The other parts of the shape are equal to 3, so 5 isn't divisible by 3. So we'd say, let's say the remainder 5 is not divisible by 3, so we wouldn't be able to split that shape up to represent it appropriately. 5A, the diagram below shows a number machine. So we've got the input and then we multiply by 6, we add 2.3 and then that gives us our output. When the input is 8, what is the output? So we're starting with 8, then we're multiplying it by 6, which gives us 48, then we're adding 2.3, so 48 plus 2.3 is 50.3, and that's our output. Part 2, when the output is 34.7, what is the input? So if we're starting with the output, we're going in the opposite direction, so we need to do the inverse operations. So we're starting with 34.7, but instead of adding 2.3, we're going to subtract 2.3, which gives us 32.4. And then instead of multiplying by 6, we're going to divide by 6, which is 5.4. Part B. The diagram shows some boxes and some balls on a balanced scale. All the boxes have the same mass. All the balls have the same mass. Calculate the mass of each box and the mass of each ball. Okay, so because these scales are balanced, these boxes must total 6.5. So we've got 1, 2, 3, 4, 5. So 5 boxes is 6.5 kilograms. So I can use that information to find one box. The opposite of multiplying by 5 is divide by 5. So 6.5 divided by 5 tells me that each box is 1.3 kilograms. Now let's equate this scale. So we've got one box plus 2 balls. Let's call the balls C. Bit weird, but we're going to do it. They equal 5.5. Now we know that a box is equal to 1.3, so we're going to replace the box with the 1.3. Now I'm going to subtract 1.3. And then we're going to divide by 2. So the mass of each box is 1.3 kilograms and the mass of each ball is 2.1 kilograms. Question 6. Philip has 250 coins in his money box. 22% are £1 coins. 2/5 are 20p coins. The rest are 10p coins. Part A, how many £1 coins are there in Philip's money box? So 22% of 250 is £1 coins. So I'm going to find 22% of 250 by multiplying by 0.22. 0.22 is the decimal equivalent of 22%, so I can use it as a multiplier in this instance. So times by 0.22 tells me that 55 of those coins are £1. So he has 55 £1 coins. Part B, how many 20p coins are there in Philip's money box? So we're looking at 20p coins now, and it tells us that there are 2/5. So we're looking for 2/5 of 250. Two ways you can do this. You can write the answer in the fraction in your calculator and times it by 250. Or you could divide by 5 and multiply by 2. So there are 120p coins. What is the total value of the coins in Philip's money box? So total value here. So we've got 55 times £1, which is £55. We've got 100 times 20 pence, but I'm going to call that 0.2. So times 0.2 equals £20 in 20 pence. The rest of the coins are 10p coins. So we've got 55 and 100. So 55 plus 100, that's 155 of the coins. We've got 250 in total. So if I subtract what I know, that tells us that there are 95 10p coins. So we're going to do 95 times 0.10. So 95 times 0.1, which is £9.50, and then we're going to find that total. So £9.50, add 20, add 55 is a total of £84.50. Question 7. Reem has made a scale model of her car. The diagram below shows the plan view of her model. And it says here the scale is 1 centimetre represents half a metre. So what I'm going to do is half a metre is 50 centimetres. I know that, so I'm going to write that there in case it helps me later. Part A, find the length of Reem's actual car. So we're finding the length of her actual car. So we need to find the length of this diagram to start off with. So making sure your ruler's flush here on 0. So the length of the car is 8.6 centimetres. So 1 centimetre represents 50 centimetres in real life. So 1 gives us 50. So let's call that the drawing and real life. we've got 8.6. So if we times by 8.6, it should tell us the real length of the car. 8.6 times 50 is 430 centimetres, or we could say that is also 4.3 metres, which is a more realistic measurement to use for a car, isn't it? Metres rather than centimetres. Part B. The height of Reem's actual car is 1.7 metres. Calculate the height of the model car. Give your answer in centimetres. Okay, so let's do another proportion table because I like to organise my information. So we've got the drawing and we've got real life. So on the drawing, 1 centimetre is 50 centimetres. In real life, her car is 1.7 metres, which is 170 centimetres. Okay, so I want to find out what it is here. So what I'm going to do is I'm going to divide 170 by 50. That tells me that we need to multiply by 3.4. So when I multiply by 3.4 here, 1 times 3.4, it's 3.4 centimetres on the diagram.